everybody, welcome to the channel. I had a whole bunch of videos on the camera and somehow it got corrupted, so I lost a whole lot of footage in regards to doing some CNC plasma work to make the enclosure, as well as my new box that I got from Weaver that will hold all the electronics. So we'll just kind of make this a hodgepodge video to kind of give you an update of what's going on. I had ordered a box from Weaver, or got it on eBay, but it's made by Weaver. Really good price for the boxes, and we'll give it a show. I started getting ready to drill and mount all the connectors into it, but this is the Weaver box. The paintwork matches really well. So it comes with a little key, open it up. So this is going to house all the electronics. I already have it pre-mounted to my column mount that we made in a previous episode. But as you can see, the paint matches really well. The box is really heavy duty. It comes with a insert that goes inside. I've already pre-mounted test fit my electronics on there. I got the connectors on here. So you can see this is just a blank board of my interface board. One of the prototypes. This is the stepper driver for the stepper, and then underneath this is a buck converter. So it takes the voltage, a DC voltage, a higher DC voltage, and steps it down to basically I need 24 volts on this system. And I plan on using the Tormach provided ATC connector on the machine, but that has 72 volts on it. So that's what the buck converter is for. So I'll be taking the power and also have inputs for the VFD, which also goes to this board, but it's really mainly needed for a BT spindle. So in the future, if I want to upgrade to a BT spindle, I already have it pre-wired and the board's already designed for the BT spindle. So this plate mounts inside the box, and I got it out, so I got everything placed on here. So we're ready for electronics at this point. We'll cover that on a separate video when it comes to doing electronics and the wiring of it. It's pretty simple, but we're going to make a separate video of it. I believe I covered it in the previous episode. These are my pneumatic solenoids. These are 5-way, 2-position solenoid valves, and one is to run the power drawbar, and the other one is to run the air cylinder on the ATC that drives the rail in and out. I ended up making a manifold system for it. So it has the air input on one side, and then the 2 exhausts for the 2 solenoids on here, and these top 2 fittings for the, depending on which side you're going to be on, the in or out. So when you change positions, the solenoid switches air to the other position. When you release the signal, the solenoid shuts off, it drops and goes out the other position. So those are done. That manifold will be in my plans. So you'll be able to get these particular solenoids. These are the model 4V110-06. They're 24 volt solenoids. Then we have the ATC. We'll kind of cover some of the stuff that I went through. So I plasma cut all of the parts for this particular system. This is the enclosure door. It's a much thicker piece, so it's designed to be for an 1/8 inch. So this is 11 gauge steel. It still has the dross on it. I haven't even cleaned these up. This is an extra one I've already built. Like I said, we lost footage. This is a plate that has the notches in it for the enclosure that goes on the drive assembly. And then here's the top of the enclosure, and you can see the notches on there. And then this is the skirt that's already pre-cut and notched. I've already assembled the ATC enclosure, so we'll go over that. I did this without a slip bender, so I had to manually bend it around an item that was fairly close to the diameter of that, so I was able to get it bent. and to weld it up. I welded it with my MIG, and then I polished off the edges and powder coated it. So I have basically all that completed. So like I said, again, I apologize. I lost a whole bunch of coverage on it. We got to see the plasma cutter in action, but we lost all that. And so what I'll do is bring the camera over here so you can see. Here is the ATC, and I have the covers on, and they're all powder coated. So these are the wires coming out. I still have to drill a hole and put my power drawbar release button for the electrical, so it'll come out here and be able to connect to the box, because the box is going to sit right back in here with that right there. Also, I have my actuator arm on here that whenever this slide goes out, this lever here pulls the door open and allows it to be seen on there. So what I'll do is, let me set the camera back up and kind of give you a little action video here. So we have, elevate it, so voila. So when it slides back, you see it pulls the door open. Whenever this goes back forward, it shuts the door. So really nice. I don't plan to use air blast at this point, even though my circuit board is designed to have air blast on it. And because of, you know, the room and stuff that's inside here, I decided not to include the air blast, because I don't really think it's going to need it because it's enclosed. So that keeps all the swarf from making it to the surfaces on there. If I end up needing it, then I will add it. I have a separate solenoid. I've already bought it anyways. And I have to just tie it to the input side with a T, because it's only a two-way, one position or two position valve. So it's in and out, that's it. So this is all covered here. At this point, like I said, we're left with just the electronics. The electronics is super basic. The board that's on here is, like I said, a prototype. I'm on my third revision. I've added some features to the board and made some improvements, and also fixed a couple issues that I've had to, you know, hand wire on the previous circuit board to make it function. Also, what I had ordered normally closed proximity sensors, and I needed normally open, because the Tormach firmware requires a normally open position. And when this slides, and you can see right here, this is the flag that goes over this proximity sensor. You won't be able to see it on the bottom. It's starting to get kind of heavy. So here's the carousel assembly, and underneath there's another proximity sensor that's mounted to it. All in all, it looks awesome. I'm so excited. I'm ready for this to be done. I had a couple special connectors that match up to the Tormach. I could only find being sold in China. I know that they're maybe in Europe. They may have some, but in the US I couldn't find it as far as a local or eBay or so. I bought the connectors on eBay, but they're coming from China. So I'm waiting for those connectors. It's a 5-pin connector that ties to the Tormach ATC plug. And then after that, we're ready to start wiring. I apologize, I lost a lot of footage that you could actually see how certain things were made and get some pointers from it. But in the interim, we're done with this. I'm going to, the next episode is going to be focusing on wiring up the electrical and connecting the pneumatics. Oh, and by the way, on the pneumatics, I have to get a extender, not an extender, but a PVC, or not PVC, an MPT pipe nipple to go in here and put a coupling on it, so I can put my flow control valves, so that when you hit it with pressure, the ram is not hammering the thing in and out. So this is what slows down the actual air movement, so it gradually feeds air to it. And so and then these are adjustable to adjust the flow. And I need one for the left and right, or the in and out side. And this one it's too short coupled, so it's going to hit the back plate on here. So I need to extend it out a little bit with a pipe nipple, so it'll be able to sit like so. And I want all my controls, because once you have this in the machine, the only way to really access anything is to pull your back cover off of your enclosure. And I want everything to try to be right at the ATC, so henceforth these go on here at the ram, so I can actually, you know, work at it through the actual front entry of the machine. All right, we have our ATC set up, and I'm hoping this is my final revision on the actual board. So far I've pre-tested everything and it's working. The only thing I have a question on is I don't have a BT spindle, so I got to find out if the brake is engaged all the time or not, because I don't have it activated in my system. So I had to find out about that. Anyways, everything's assembled, other than I need to hook up air so I could cycle it. But for the most part, I can still test my proximity sensors, which work. I home the carousel, which is all good. I don't plan on using air blast, but I do have it set up in the system to do a blast, simply because I have an enclosure to keep the chips off of the tool bits that are currently in place. If I do, I may try to fabricate something, a nozzle off of the side on the inside of it here, so it'll blow onto the actual tool fork section. I have to put my power drawbar button in here, so I still have to drill a hole in here, but I do have all the other wiring coming out. And then my solenoids, like I said, these are for the power drawbar and the ATC air cylinder. I have it set up on the back plane. It's kind of a rat's nest, but this is testing. When it's all done, it's all going to get all nice and cleaned up and be in the box. It'll look nice. So anyways, I figured I could give you a little showdown. Sorry, the way my screen points towards the outside of my shop, I can't see it with the camera. So but I'll show you the ATC little reference, so you can see it spinning around, references, and then I can drive it. You know, when you're trying to align it, you can see it. I'll click it, you can see little tiny movements. That is so you can do adjustments, you know, for doing the alignment on your ATC. So all in all, it's ready to go. I'm still waiting on my connectors to get here. Once the connectors are here, then I should be able to completely wire it and be done with this complete system. I'm running it on a 24 volt power supply. When it goes into the machine, it's going to use the machine's 72 volt power through a buck step down power. You know, it's basically just a step down. It takes a higher voltage DC in and then outputs it to a predetermined. You set it, so I'm going to be setting it to 24 volts because the system runs off 24 volts. Kind of give you a background of this prototype board. You can see there's an array of LEDs on here. I have the two greens are my supply voltages, one being 5 volt and the other one being 24 volt. When those LEDs are on, that means the power is applied. And then where the red LEDs are for each one of the solenoids. So when the solenoid gets activated, an LED will turn on. So currently the brake for a BT spindle is activated. This is the stepper driver. I included in, because this is wired with PNP, so I have a 5 volt source on the stepper driver, so you have a step and direction signal that comes out and comes into the step driver, and then also a 5 volts that comes in and supplies to the step driver, and then everything else is to the motor. These little wires here represent my push buttons. It's an in and out. So one is the air switch or air pressure switch. So you would have a normally closed, I believe it is, pressure switch. So it'd be a low pressure switch. So when the pressure drops below a certain PSI, it completes the circuit. So when you complete the circuit, you get a notification on the machine that you have insufficient air pressure. The other functions is for the power drawbar. So when you push the button, henceforth shorting it out onto the other one, it functions the power drawbar. So all in all, everything's working great. So stay tuned. Once my connectors get in, we're going to do a full build on the actual electronics chassis and try to cover a little bit more on it. So anyways, stay tuned.